Hi, in this particular video we're going to be looking at sine rule word problems. So there's a couple of problems for you to have a go at. They are really quite challenging. You need to use a couple of different methods in order to be able to solve the questions that are being asked. I hope it's useful to you. Please do add a comment below if you're not sure about anything. Always come back to, and always please do stop the video. Have a go. Compare your solutions. I look forward to seeing you inside the video. Hi, in this video we're taking the sine rule and we're looking at word problems. Now I appreciate number one isn't strictly speaking a word problem, but I thought it was important to look at because it actually asks you to work out the area of a triangle. So please do add a comment below if you're not sure about anything. I'll always come back to you, but also stop the video, have a go at each of these questions and then compare your solutions. You can also download this worksheet through the website 3 Minute Maths. Okay, so the area of triangle ABC. Well, the way to work out an area of a triangle, there's two different rules that you can use, or formulas, one of which is a half base times height, which a lot of people use, but also you can use this formula. You can say area equals a half AB sine C. Now, hopefully you've come across that. It's actually on the front usually of a GCSE exam paper. The formula's at the front, but certainly a very useful formula to remember. So basically, this formula works on the principle that it's an inclusive angle. So I could say this is A, and this is B, this line along here, and this is the inclusive angle. Now, unfortunately, we don't know this one, okay? But we're going to find a way of working that out. And when we've got this, and this angle, we can use this formula. So the first thing I'm going to do is I'm actually going to say, well, at the moment, I can put B over this length B and use the sine rule for it, okay? However, I need to have this angle, because if I've got this angle, it just means I can straight away work out this length along here. Okay, so in order to work out this angle, well, this is going to be 180 minus 134 minus 26. So it means this angle is going to be 20 degrees. Okay, so now I can start applying the sine rule in order to find out this length AB. Now, bearing in mind with a lot of these, they don't make it obvious. So one of the things that they do is they might change a little bit some of the designations. So I'm going to actually make that A, okay? Because then it allows me to write A, which is this length along here, which is what I'm looking for, over the sine of A equals B, which is 10.4, which I've already got, over the sine of B, which is 26 degrees. Okay, so let's have a look at putting in some numbers. So A is what I'm looking for, this length along here. The sine of A is the sine of 20 degrees, and that equals B, which is 10.4, divided by the sine of B, which is 26 degrees. Okay, so therefore it allows me now to change this formula and make A the subject and say, actually, I want A, which is going to be the sine of 20 multiplied by this fraction, 10.4 over the sine of 26 degrees. Okay, put that into a calculator and I'm going to get that A equals 8.114. Okay, so that's good news because now I've got two sides, this side, and I've got the inclusive angle. So now it allows me to work out the area of this triangle using the formula. So the area equals a half AB sine C. So a half and A is going to be 8.14. I'm just going to put a little dot in there. It just means multiply. It just makes it a little bit easier for me. And then B is going to be 10.4. And then the sine of C, well, in this particular case, it's going to be now, this has become C, so it's going to be the sine of 134 degrees. Okay, when I calculate all of that out, I'm going to get 30.3515 centimeters squared. Okay, so I could, if I wanted to, say that the area equals 30.4 centimeters squared, and that's to 1 decimal place. Okay, so a little bit more challenging. These type of questions are aimed at round about grade 6, grade 7. They do take a bit of working through, and you will need to have a bit of confidence in dealing with a couple of different formulas. If you're not sure about anything I've done, please do add a comment below, but also have a look at the other playlist on sine rule calculations, and that'll give you some idea. Okay, so let's have a look then at this particular question, which is a grade 7 type question. So it is going to be much more challenging, but hopefully you'll be able to kind of work through. So please do stop the video and have a go. Okay, so what have we got? Well, we've got a flagpole. It's got 2 wire ropes, A and B, or A to the top of the flagpole. Okay, and it says from point A, the angle of elevation is 65 degrees. So in other words, what we mean is this is 65 degrees. Okay, and the question also says from point B, it's 78 degrees. So in other words, you're looking up to the top of the flagpole. Okay, but don't let that fool you too much, okay? Because essentially what we've got here is 2 triangles. We've got a scalene triangle, which is this one here, which we're going to use in a minute. And then we've also got this one here, which is a right angle triangle. And in this particular case, we're going to use the properties of right angle triangles in order to work out the height of the flagpole. Okay, so before we do that, however, what we need to do is work out this length here, which I'm actually now going to call A. Okay, so I'm going to use the sine rule to figure out A, but in order to do that, I need to know that the distance from A to B here is 7.8, and I need to know this angle at the top. Okay, so hopefully you can see this on the video all right. So in order to work out the angle at the top there, well, basically I've got this triangle. But what I know about this triangle is this angle at the bottom is going to be 102 degrees. Now, the reason I know that is because this is a straight line. So therefore, these 2 angles must total 180. Okay, so if I know those 2 angles are 180, I know that's 102, and I know that's 65. So if I add those 2 together and take them away from 180, I'm going to get this angle at the top, which is 13 degrees, okay? So now I'm in a position where I can write my sine rule as being A over sine A equals B over sine B. And what I've effectively done is I've said, well, okay, this is A and this is small a. This angle at the very top here is B, and this is lowercase b. Okay, so therefore, if I start putting in the numbers now, I've got A over the sine of 65 degrees equals B, which is 7.8 divided by the sine of 13 degrees. So if I make A the subject, what I'm going to do is be able to work out this length of this rope. Okay, so let's have a look. We've got A equals the sine of 65 degrees multiplied by this fraction, 7.8 over the sine of 13. And if you put that into a calculator, what you're going to get is that A equals 31.4255 and so on meters. So what that's telling me now is that the length of this rope is going to be 31.4 meters. So let's now draw this out as a separate diagram. What I've basically got now, I'm concentrating on the right angle triangle. I've got a right angle triangle here. Okay, nice right angle. This bit of it is the flagpole. and this bit of it is 31.4255, and this bit of it is 78 degrees. Now you'll notice that actually, because it's a right angle triangle, what I can do is I can use now SohCahToa in order to be able to answer my question. And hopefully a few of you will have got to this particular point where you can sort of see that there is this relationship with this right angle triangle. Okay, so let's put in SohCahToa. And then it's a case of labeling the triangle. Well, this is the angle here, so opposite is the length of the flagpole. The longest length is the hypotenuse, and the one that's left is the adjacent. So if I look at my ratios, the one that I'm going to look at is going to be the sine. Now, the reason I'm going to use the sine is because I know the hypotenuse and I know the sine of the angle, but I actually need to work out the opposite. And again, if you're not sure about any of this, please do have a look at the SohCahToa type videos. There's quite a few of them on the channel itself. It's a topic that comes up very, very frequently. So let's have a look then at putting in the numbers. I'm going to say the sine is equal to the opposite over the hypotenuse. The sine of 78 degrees equals the opposite, which you and I know is the flagpole length, and the hypotenuse is going to be the one that we've worked out, 31.4255. So I now need to make the opposite the subject of the formula. In order to do that, I multiply both sides by 31.4225, so I've got opposite equals 31.4255 multiplied by the sine of 78 degrees. So therefore, when I put that into a calculator, I'm going to get 30.73878, and that is the opposite, which is actually the length of the flagpole. So therefore, the answer to this particular question on the height of the flagpole is going to be 30.7 meters, and that's to 1 decimal place. Okay, I hope that's been okay for you. A bit of a long, fairly challenging sort of video to kind of work through, fairly challenging question. It is aimed at around about grade 7, so hopefully it's giving you some idea about how you can approach these types of questions. Please do add a comment below if you're not sure, add a like if you found the video helpful, subscribe to the channel, and I'll look forward to seeing you inside the next video.